So this is this is the graph of what we just did. This is a slope field of 2x over y, and what I'd like to do is I want to kind of show you, like, well, you are probably the better judge here, because I'm about to click on these solutions here, and you'll see why there's certain limitations to these slope field graphers. Okay, what does the general shape look like to you? Now we haven't taken the integral of this to see what the solution looks like, a particular solution could look like. Okay, but what does it look like to you? Do you remember graphing stuff like this in pre-calc? I don't know if you can notice, like, to me, can you kind of see that this guy looks like this is going to be a parabola here, but then it also has this shape here at the same time. So this guy, this looks like a hyperbola, and it actually looks like a hyperbola over here as well. Okay, so this is actually the differential equation of hyperbolas, okay, of a certain kind of hyperbola. But notice what happens when I click on the solution. Sometimes these graphs, they're not perfect. They're still kind of in like a rudimentary phase. So you can kind of see that the hyperbola was working until it just totally glitched out past 1 and then does this weird stuff, okay? Now, is this a possible curve? I don't think so. I think they're following the rules, but what happens is that they make a jump here in the program, and I think it just kind of glitches out, okay? But you can see the making of a hyperbola there. If we look at solution B, you can see this is a little better. It swings out, but then notice that this goes to an undefined slope. So it's that's weird, right? Same with this guy. This looks good here, but then it just glitches out right here as soon as the slope gets vertical. Okay, it just doesn't like it. So it's kind of interesting. The grapher can help out, but you got to kind of know that there's certain pieces of it that are going to just kind of like freak out once it encounters like an asymptote or something. Okay. All right. So we get an idea and feel like it's a hyperbola. So let's actually go and take that general. Let's find the general solution to this. All right. So we're going to then use it to solve for the general solution. So let's go ahead and do that. Now what I'm about to do is I actually see, now we're used to seeing this as a single unit. Oh, is my camera working all right? All right. We're used to seeing that as a single unit. Okay, but actually this is cross multiplication. Okay, so I got a y dy equals 2x dx if I cross multiply. And when I integrate both sides, okay, I've got myself a little, I've got two of them, right? So this guy becomes 1/2 y squared plus c. And then this guy becomes x squared plus c. Okay, so now if I actually put these guys together, all right, this guy, well, actually, let's multiply everything by 2. Let's multiply this 2. Let's get rid of that fraction. And then we'll move this guy over to here. Oh, no, I'm sorry, my bad. Multiply by 2. And then we'll move this guy over here. So multiply by 2 and 2. Now, I can multiply the c's by 2, sure. Okay, doesn't matter, but c could be anything, so 2 times anything is still anything, okay? So we're going to move this guy over here, all right? So 2x squared equals, and then we've got the c's. This guy added to this c is just still another general c, so the c can be any constant whatsoever. And if you remember in pre-calc, that is a hyperbola right there. It's general shape. And if you remember that this guy always had to equal 1, okay, so it looks like we've got y squared over some number minus 2x squared over some number equaling 1. So this is a hyperbola that essentially is going to have like that kind of shape, okay? All right. Yeah, because the y is squared. All right, and the c's could be anything. We don't know. It's just a total general group. All right, so this one right here, we're kind of doing the same thing. We're just kind of filling out charts, making sure that we understand like what this graph is, like what is it doing, okay? Now this whole page is just going to focus on this equation right here. So I want you to know that everything in these tables stems from this guy right here. Okay, that's where we're going. So all they're asking us to do is fill out a table for here, and if we fill out these guys, just answer a few questions, and then we'll just graph it here, see what he actually looks like, and then we'll stop. So if I plug in a 1, 1, I don't know if you notice, but it plug in a 1 for x, 1 for y, we get a negative 1. Negative 1 for x is positive 1, divided by 1 is positive 1. Negative negative would give us a negative 1, and then this guy here is 1, that becomes negative 1, divided by negative 1 is positive. Hopefully that wasn't too fast, but that actually is just, I'm just plugging in here, and you're going to have some double negatives and some single negatives, figure out which one is which. Okay, now I could take these values here and actually go down to part F and graph them. Okay, I could graph them if I wanted to, but what I want to point out here is what they've done is they've shown you that this is actually in quadrant 1. Negative 1, positive 1 is actually quadrant 2. This guy is quadrant 3, where they're both negative. I don't know why I wrote in Roman numerals and then didn't here. And then this guy is actually quadrant 4. Okay? So basically, they're just giving you 4 different values in each of the quadrants. So where is this guy positive? In what quadrant? Well, 2 and 4. All right? Now that could absolutely be a question on the AP exam. That's it. And that might actually be all you need to know about slope fields, because you need to know what's going on in the slope fields for you to answer that kind of question. I think I just said that in a circle. Okay. Negative, it's going to be in quadrant 1 and in quadrant 3. Okay, we'll put a Q in front for quadrants. All right. So next, let's just say that we got 1, 0. Okay, what if we got 1, 0? If we put a 1 in here and then a 0, oh, nope, that's no good. Undefined. Oh, looks like we've got undefined for each one of these. Okay, so write an equation that would describe the slope as undefined. So what is that? When the slope is undefined, what are we actually going to have? Looks like if the slope is undefined, then it looks like our x can actually be any value. Okay, it can just equal a number, and then y would be 0. Okay, where is the slope 0? The slope is 0 when basically y equals whatever number. Okay, meaning then that the derivative has to be 0. Okay, and then if the derivative is 0 across, then it would be a y equals that value for y. Okay, so in a way, like if x was 0 here and y could be any number, then you would have a y equals b because x was 0. Okay, so in a way, you can kind of look at it like this. Okay, so if x was 0 and b was some number, then you would have a slope of 0 there. Okay, and likewise, if a was there, okay, this is what we have in our chart. This would be a different chart. Okay, all right. So now let's see what they're asking here at 1, 1. I think we already answered that, right? At 1, 1, it's negative 1. At 2, 2. Okay, so 2, 2. 2, 2 would be negative 1. Looks like negative 1, negative 1. That would give us negative, negative, and then that's positive, so divided by negative, that's a negative 1. And then at negative 2, 2, sorry, getting dizzy, it's also negative 1. These guys are all have a slope of negative 1, okay? So, write an equation that would express the dy dx equaling negative 1. So you can see that it equals negative 1 whenever the x and the y coordinate are actually the same. When they are the same, you're going to get a slope of -1. Okay, that's all that it's asking. What to get a positive 1? Well, if you were to get a positive 1, then it means that the x would have to be positive and the y would be negative, right? So what they're asking here is, where are the quadrants here that would give us a -1 here? This would happen in 1, 1, and 2, 2. That's quadrant 1. These guys are in quadrant 3. So in quadrant 1 and 3, you're going to have slopes of -1 at these points. And then here, if I wanted these guys to equal 1, if I wanted the derivative to equal 1, then this guy would have to be a negative, and he would have to be positive. So a negative x and a positive y is actually quadrant 2, okay, and quadrant 4. So that would give us that right there, okay? And so this line, when they equal each other, and then this line when they equal each other. Okay? Okay. Now, I'm actually not sure exactly why they ask this. Okay, and I don't know if my explanation for this was, I feel like after I just said that, it was unclear. Really, fundamentally, what we're looking for here is to not necessarily get the equation to, if we graph this, that we would know these things, okay? So getting the equation, it just seems kind of strange, and me writing a line here doesn't mean too much. It just means that, you know, we would need the x to be negative and the y positive in order to produce a positive 1. Here, they have to be both the same sign in order to produce a -1 because of the way that function is, okay? All right, so now what we can do is we can actually graph this guy, all right? And you could basically put out a table here and just kind of graph along. We can graph what we know, and we know at 1, 1 that's a -1. So let's just graph what at 1, 1 is a -1. At -1, 1 is a positive 1. Okay, at 1, 0 is 0, and that's from this table. Oh, no, sorry. 1, 0, 1, 0. No, I meant to say 0, 1. 0, 1 is actually 0. Okay, in fact, if you look at this guy, if you notice if your x is 0, it doesn't matter what the y is, so it looks like we can actually fill these in. Oh, can't do this guy. If you notice that all of our y's are undefined, because if y is 0, we're going to have a vertical tangent line. Okay, that would be an asymptote. So all of these guys are going to look like this. 0, 0 would be 0 divided by 0. I don't even know if that's even defined there, but you're going to have kind of like this action going right here. Sometimes some people will not even graph the vertical lines. They'll just kind of leave them blank. All right, but we can, just because it's relatively early in our gameplay here. If we got -1, -1, -1, -1, do we have that? -1, -1 is actually -1. And then 1, -1, I'm sorry, yeah, 1, -1 is actually positive. All right, now I don't know if you can tell what we've got going here, but if we took the antiderivative of this, I think you will find that these guys kind of, okay, notice these guys are slopes of -1. That's what that table just told us, okay? And then if we got our quadrants going across here, we got +1 here. Does that look like something? Yes, you are correct. They are circles, Okay, they're all circles. And so this is all that we need to kind of see that there is basically a circle in each situation. Okay, the only thing that's changing is the constant. And for us, that constant would be the radius. Okay, so we just did D. That's the sketch. This is a long video. Number 2, when we get to E, draw the particular solution that goes through 0, 2. So 0, 2 is right here. So basically, if it's a circle, we're talking about this guy right here. Okay, that is, all right, what is the equation for this guy? Let's see. A circle with a radius of 2 and a center of 0, 0.
Am I vacuuming camera back?
Yeah.
You sure?